Today I'm going to walk through the creation of a list using the C++ standard template library. The standard template library is a set of classes given to you by the C++ gods that allow you to build things like lists, arrays, vectors, sets, stacks, queues. Any data structure you've heard of exists here. They all set up pretty much the same way. They also have some of the very same basic algorithms like adding to it, searching, sorting, etc. When you build one of these STLs, to walk through it, we're going to use a tool called an iterator. Now, not all of these objects allow you to walk through them, but those that do, the iterator is usually the fastest and best way to go. Today, we're going to build a forward list, which works like our singly linked ordered list from the book. These are lists, as I've talked about in class, are really good if you have items that just simply need inserted. You're pulling them from a file, you're pulling them from people, whatever. You just simply need to throw them in RAM, and you'll deal with them later. This list does not contain the size elements. You have to either count it or use some type of distance formula. The primary method you use to insert is insertion. There's insertion called push front, and it's pretty easy to set up. All right, so I have some stuff built here. For forward list, you need to include forward list. You'll need iterator so that you can walk through this list. I'm including algorithm for a search in a minute and fstream because I'm reading from a file. This read file function I have down here is going to add to my list, and you see how I have push front ln. I read from my file and I push and put in front of it. I do a count here just so I know that it works and it read. And I have 50 files of nouns and 50 words of adjectives and files that I'll read in. And I did this off camera because you guys know how to read files. So let's create our forward list. So all the C++ template objects set up the same way. Name the template object, and then the data type you wish to hold in angle brackets. We're going to give it a name. So I've got forward list, adjectives, nouns, and all words, and all three of these will hold strings. If I want to simply add something to that particular list, I'm going to do looks like I've never typed before. That puts it in my list. Not a hard thing to work with. Clearly, it's difficult if you want to do this in code, which is why we're reading them from a file. So, fill the list, or read the file here is going to fill this list, and it's going to ask for a file. I have adjectives and nouns, and it's going to fill in the list. You see I've got the ampersand here, so whatever I pass in gets modified back in main. And again, the magic is right here in push front. Let's see that this works. Now, I made a slight programming gaffe. My file name is adjective instead of adjectives. So I gotta make sure I get the right name there, or else it'll die. So I run this, I should get 50 lines read from each one of these files. There we go. So I know it worked. If I didn't read correctly, my program just dies. I don't have any error messages, it just dies. Bad coding on my part. All right, so we have two lists filled. Let's create the ability to show this. So let's prototype a function. We're going to pass it a forward list. So the data type of the list is forward list, angle bracket string. And again, string is whatever data type you want. You can use any data type, so you can use any of your custom classes. Just make sure you also define less than, greater than, and equal. Those have to be defined. All right, so now let's write this method. And I'm going to build an iterator. Now the iterator here is going to be of type forward list. Word is a pointer to something inside of a forward list of type string. So since it's a pointer, we can access the actual value by using a dereference. Now in the past, in order to walk through an array, we built a for loop that went from 0 to the size of the array. I don't know how big the array is or the list is, because remember, it doesn't have a size object. Now I could easily have counted that and held on to this 50, but I don't want to limit myself to just sizes. So I'm going to use some really cool tricks that iterators use. Here's the first one of these. I'm going to do the list.begin. This is the beginning of the word, the list. You notice the before begin dropped there, and that is actually literally before the list begins. It's the memory location right in front of memory. Keep going as long as word is not equal to the end. The end is not the last word in the list. The end is after the last word in the list. And I word plus plus it. So it's a for loop, but instead of zeros and sizes, it goes beginning end. This is a very easy for loop to read. Now to output it, word is a pointer, so I got to dereference it. And let's make sure that it works. Let's display our nouns. And they come back. See they come back alphabetically. Now that's on purpose. The forward list is an unordered list. By default, it's unordered. When I read this in, I sorted it. And you see how easy it is to sort a list. You simply, at the end of the list, sort. If I take that line out and rerun this thing, quite obviously, my list of nouns will not be in alphabetical order. It'll be in order of the file. Now that sort here is a very quick sort because I'm still dealing with a list, which are pointers. So to rearrange the order of something in the list, I don't have to move them in memory. All I have to do is change pointers, which is a lot faster than sorting an array. So lists are excellent if you need to quickly pull something in and quickly sort them. They are a very fast tool for that. I'm going to leave that out because I'm going to sort later. Alright, so I know it works, and I can put adjectives in there. But you notice I created this list called all words, and now I'm going to merge these two. There are many ways to pull this off. Okay? I'm going to use a splice technique. Splice after does what it says. It takes in a list and puts it after wherever you want it to start. I'm going to tell it to start at the beginning. Alright, so I've now built all words using adjectives and nouns. Since they both are being spliced in before the beginning, nouns will be first. You can play with a lot of different positions in here. I'll let you guys play around with that. Run this thing. and I have my 50 words. Let's sort them. Not surprised, they're alphabetical. I hate this output. I'll make my output a little better. Just because I can. Instead of end-nailing each one, I'll put 5 on each line. So I'm going to use a couple modifiers. So I'm going to have 15 character wide columns. And then every 5, I'm going to do a new line. Again, this just makes it look prettier. I do like pretty output. I forgot to increase count by 1. There we go. Nice columns. Okay, so you have a list in memory. Lists are not really good for retrieving items. They're good for reading in, storing, maybe displaying, or writing somewhere else. Like if you were to move something from a text file to a database and you had to do some manipulation, a list would be good for that. They're not really good for searching and retrieving data, but you can search a list. To do so, that's why I included algorithm. Use one of the tools in algorithm called binary search. Binary search is the fastest search we have. It depends upon a sorted list because the way it works is it'll find the middle of the list alphabetically, and if the word it's searching for is below the middle, it'll eliminate the entire upper half and then just search in the bottom half of the list. And it'll keep doing that. It'll keep cutting the list in half and eliminating the half of the list that the word can't be in. It becomes a very quick sort. It's typically on the order of It's typically on the order of O log n, which means if you had a list of 1,000 items, it would take about 3 looks to find it, which is pretty fast. In reality, it's a little slower than that, but it's still faster than looking at 1,000 items. So let's search it. I want to see the word I want to find. So I want to see if cell's in the list. And I know cell's in the list. It's right there. So this should work. I'm going to use binary search. Binary search has 2 properties. Both of them are bool. What I'm going to do is I'm going to make it search for a particular word. So looking at all words, start at the beginning. I'm going to go to the end. I'm going to search for a word. Binary search returns true if it finds it, false if it doesn't find it. So it's either there or it's not there. I'm just going to copy it because I can't type. Now we know it's there, so I'm going to comment out my list. Oh, what I forget. I lost a semicolon. Okay. There it is, cells in the list. Now, just to make sure that I didn't screw this up, I'll look for a clue. And clues should not be in the list. Clues not in the list. Okay, binary search depends upon the list being sorted. If you don't sort the list, weird things happen. So it's not in the list. Look for cell, which we know is in there. It's not in the list. Now, when I say weird things will happen, is it will actually search the list, and it will search in the middle. And if you happen to search for the word that is in the middle, binary search will return it back. So you might get lucky and it will find it, but it's not consistent. It has to be sorted. So I sort it. binary search beginning to end, find it, and it's back there. Now you can use binary search on just about any object in the STL library. So it makes for a very fast search, but again, the object has to be sorted, and if it's something other than string, you have to make sure you define what equal is, less than, and greater than, because that allows it to be sorted. Alright, so we have built an object from the STL called Forward List. They all pretty much set up the same way. STL object, data type you want it to hold. Some of them will have commas, we'll see that going forward, but typically it's STL object, one data type in the angle brackets. Give it a name. Learn how to fill it, learn how to parse it. That's it. Good luck to you. Thanks for listening.